In this example, we design low-pass Butterworth filter to meet the following specification given the value of omega passband, omega stopband, attenuation passband, and attenuation stopband. So first we determine the discrimination factor based on this formula. So we use the value of attenuation passband. So this is negative value, so it becomes positive here based on this negative formula. And the next one, we use attenuation stopband, and this is the value for discrimination factor. The second one, we calculate the selectivity factor based on the ratio between omega passband and omega stopband. So based on these two values, the selectivity factor is 0.6667. The third one, we determine the filter order n based on this value of the discrimination factor and selectivity factor that we have calculated in the previous slide. So we rounded this value, it becomes 3. And the fourth one, we compute the 3 dB cutoff frequency omega c based on the range value, which is larger than this one and smaller and equal than this one, using the value of omega passband, attenuation passband, filter order n equal to 3, based on the value of omega stopband, attenuation stopband, and also filter order n equal to 3. Therefore, we have this range. Now we need to select the value of omega c, the 3 dB cutoff frequency, among this range, between this range, which is larger than this one and smaller than this one. Therefore, in this case, we select omega c equal to 0.5. The next step, we determine the left-hand side pole based on this formula. So this is the magnitude and phase based on the value of omega c that we have selected from previous slide, 0.5, and for the phase it is n plus 1 equal to 4 plus 2n multiplied with pi divided by 6. We need to calculate the pole for n point based on n from equal to 0 until n minus 1, which is 2, and then we substitute the value of n in this formula for n equal to 0 until 2. Therefore, we have 3 poles based on this formula. The next step is to determine the system function based on the synthesized formula, which is the production with limit n equal to 0 until n minus 1, which is 2. For left hand side, we use the value for omega c that we have select from the range 0.5 with the filter order 3. For the pole, we have 3 poles, meaning that we need to repeat this step 3 times. Just multiply this function, and be careful when you plug in the value of pole, you need to invert the polarity from the determined value of pole since this is negative. So this is the system function that has been synthesized based on this frequency formula in S domain.